We've got a question here that's asking about some combinations. We've got 3 boys and 4 girls, which makes 7 people altogether. So when we're asked what the total number of possible arrangements are, if we think about it, we could have any number of 7 people in the first position and 6 people in the second position, 5 in the third, and so on and so on. And what we call that is 7 factorial. So the answer for part A is that we could have any number of 7 times, 6 times, 5 times, 4 times, 3 times, 2 times 1, which is 7 factorial people in the first or in the total positions. And that means the total number of possible arrangements is 5,040, which is 7 factorial. Now, if we have the 3 boys together, then what ultimately we have is the idea that we have the 4 girls could be anywhere amongst the 7. But the 3 boys need to be all together in one of the groups, which means altogether we have 5 groups of people. We've got 4 girls and 3 boys. The boys could all be first and the girls in any number of different orders then. Or out of the 5 groups, the boys could all be second and the girls in any number of groups, or third or fourth or fifth, and so on. So if you look at this scenario, there are actually 5 different combinations that you could have, or 5 units that could be in any order. But then if we have a look at the boys themselves, in every case, the boys could be in boy 1, boy 2, boy 3, or any of these orders. So the boys could themselves be in 3 factorial different orders. So the total number of arrangements where the 3 boys could be together is actually 5 times 3 factorial. And that's 720 places. Now for the third scenario, you have boys and girls in alternate positions. Because there are 4 girls and 3 boys, then for this scenario it must be girl, boy, girl, boy, girl, boy, and then girl. And in that case, there's any number of 4 girls that could go into the first position. The second position therefore must be filled by a boy, and there are any number of 3 boys that could go into that position. Now for the third position it must be a girl, but one of the girls is already taken because she is already occupying the first position. So there are 3 girls left. And so on, the next boy position must be one of the 2. The next girl position, there are only 2 girls from which to choose. And the final boy and the final girl, they're already chosen because they're the only ones left. Then if I bounce this idea along, I have 4 times 3 times 2 times 1. That's 4 factorial. And then for the boys, I have 3 times 2 times 1, and that's 3 factorial. So the probability that the boys and the girls are in alternate positions are the number of combinations in which they're in alternate positions, which is 4 factorial times 3 factorial, over the total number of possible arrangements, which is 5,040, or 7 factorial. So let's have a look at this idea tech-free. If I want to have a look at this expression tech-free, what I actually find is that I have a very cancelable, if you will, expression. In the numerator, I have 4 times 3 times 2 times 1 I don't need to write that, multiplied by 3 times 2, again, times 1. And in the denominator, I have 7 times 6 times 5 all the way to 1. And you can see there are quite a lot of factors here that I can cancel down. So my 4 and my 4 can go, my 3 and 3, the 2 and 2, and the 3 and 2 can combine to take out the 6, which means I end up with an expression of 1 over 35. So the probability that we line up girl, boy, girl, boy, girl, boy, girl is the total number of combinations in which I could line up that way divided by the total number of possible arrangements, and that ends up being 1 out of 35.